Topics: Solid sphere model, plum pudding model, nuclear model, planetary model, quantum model. Atomic theory timeline. 1803, solid sphere, John Dalton. Atoms are dense and solid, with no internal structure or subatomic particles considered. 1897, plum pudding, J. Thomson. Atoms are described as uniform, positively charged spheres with electrons embedded within them, similar to raisins in a pudding. 1911, nuclear. Ernest Rutherford. Atom consists of a small, dense, positively charged nucleus at the center, with electrons orbiting around it, similar to planets orbiting around the Sun. 1913, Niels Bohr. Electrons move in quantized, discrete energy levels around the nucleus and emit or absorb energy when transitioning between levels. 1920s, quantum. Owen Schrödinger. Electrons do not have definite orbits, but are described by wave functions that represent probability distributions of their locations. John Dalton, 1766 to 1844. British chemist and physicist. Proposed the solid sphere model in the early 19th century. Shifted from philosophical ideas to scientific theory. First atomic model based on experimental evidence and quantitative observations. Paved the way for the development of modern atomic theories. Solid sphere model, atomic theory. 1803, according to this theory, atoms are tiny balls that can't be broken and are all made of the same material. This theory helped explain how different chemicals mix together and what makes them different. Limitations. Couldn't explain differences in atomic mass within an element, isotopes. Didn't account for the presence of subatomic particles like protons, neutrons, and electrons. Couldn't explain the behavior of atoms in chemical reactions. J. Thomson, 1856 to 1940. English physicist known for his work on the nature of electrons. Proposed the plum pudding model in the late 19th century. Discovered electrons as distinct particles. Shifted understanding from indivisible atom to subatomic particles. Paved the way for further exploration of atomic structure. Plum pudding model, atomic theory, 1897. According to this theory, atoms are like plum pudding, with tiny positive charges scattered throughout a cloud of negative electrons. This theory helped explain why atoms have a neutral charge overall and why they emit light when they collide with each other. Limitations. Couldn't explain why electrons didn't collapse into the positive sphere. Failed to predict the distribution and arrangement of electrons. Lacked explanation for the nucleus and its positive charge. Ernest Rutherford, 1871 to 1937. New Zealand-born physicist known for his contributions to nuclear physics. Introduced the nuclear model in the early 20th century. First model to propose a central, massive nucleus. Explained the behavior of positively charged alpha particles in the gold foil experiment. Laid the groundwork for understanding atomic structure and radioactivity. Atomic theory, 1911. According to this theory, atoms have a nucleus with a positive charge and most of the mass, surrounded by electrons that orbit like planets. It explains why particles can pass through or bounce off atoms, and is the basis of our current understanding of atomic structure. Limitations. Didn't explain the stability of the nucleus against electrostatic repulsion. Lacked details about electron orbits and energy levels. Didn't incorporate the principles of quantum mechanics. Niels Bohr, 1885 to 1962. Danish physicist known for his pioneering work in atomic structure. Proposed the planetary model in the early 20th century. Explained atomic spectra with precision. Introduced the concept of quantized energy levels. Bridged classical physics with emerging quantum mechanics. Atomic theory. 1913, planetary model. According to this theory, electrons orbit the nucleus of an atom in specific energy levels or shells. This theory helped explain why atoms emit light and why they absorb certain colors of light. It also helped explain the stability of atoms and why they don't fall apart. Limitations. Limited to explaining the hydrogen atom. Couldn't account for the behavior of multi-electron atoms. Didn't incorporate the wave-like nature of electrons. Erwin Schrödinger, 1887 to 1961. Austrian physicist renowned for his contributions to quantum mechanics. Proposed the quantum model in the 1920s. Quantum mechanics provides a comprehensive understanding of electron behavior. Schrödinger's model successfully explains multi-electron atoms. Quantum mechanics is the foundation of modern atomic theory. Atomic theory. 1920s, quantum model. According to this theory, electrons exist as a probable wave-like pattern around the nucleus, not in a specific orbit. It explains why electrons act like particles and waves, and is the foundation of our understanding of atomic structure and widely used in modern physics. Limitations. Mathematical complexity of the model. Requires advanced mathematics to calculate electron probabilities. Doesn't provide a simple visual representation of atomic structure. Time to test your knowledge of the atomic theory. If atoms are solid spheres, what would happen if you tried to cut one in half? Answer dash. In the solid sphere model, atoms were believed to be indivisible, so you couldn't actually cut one in half. It was thought that atoms were the smallest, fundamental building blocks of matter. How would you describe the distribution of raisins, electrons, in this atomic pudding? Answer. In the plum pudding model, the raisins, electrons, were thought to be scattered throughout the positive pudding atom. So, the distribution of electrons was assumed to be relatively uniform within the atom. What did Rutherford's gold foil experiment reveal about the atomic nucleus? Answer. Rutherford's gold foil experiment revealed that most of the atom's mass is concentrated in a small, positively charged nucleus at the center. This discovery overturned the idea of a uniformly distributed positive charge. Why might electrons be compared to planets in a solar system within Bohr's model? Answer. Bohr's planetary model drew an analogy between electrons orbiting the nucleus and planets orbiting the Sun. It simplified the complex behavior of electrons, suggesting they had quantized energy levels like planets have orbits. Why might electrons be compared to planets in a solar system within Bohr's model? Answer. Schrödinger's cat is a thought experiment in quantum mechanics, not directly related to electrons. However, it illustrates the probabilistic nature of quantum systems, similar to how electrons are described by probability clouds in the quantum model. The cat is in a superposition of states, both alive and dead, until observed, much like electrons can exist in multiple states until measured.